So in this session, we will see how to remove and identify outliers from your data set using Python. So in previous lectures and in previous sessions, I have told you all about the z-score and the IQR method. And that was all the theoretical concepts and I told you about the formulas and solved some sort of examples. Right now, in this session, we will see the actual Python implementation of both methods, that is z-score and the IQR method. Before that, I want to just revise this standard normal distribution that you see that you had this standard normal data. And I already told you about that. This is, if this is your mean, then these are your standard deviations. This is first, second, third, first, second, third. So these are the three standard deviations. And in the first standard deviation, there is a 68% of the total data is present on this first standard deviation. And in the second standard deviation, there is 95% of the total distribution is present at the second standard deviation. In the third standard deviation, we have 99.7% of the data that is present at the third standard deviation, which means that if this is the third standard deviation, you can see that till here, this is the third standard deviation. So till here, we have all of the data that is standard normal. Now, if I say the outliers, if I wanted to identify the outliers from the normal distribution, I can say that the data that is present beyond the third standard deviation, I repeat, the data that is present beyond the third standard deviation, I consider it as an outlier. Because, like the 99.7% of the normal distribution, the total distribution of data that is present at the third normal distribution, right? Third standard deviation. So I can consider easily that all of the data that is present beyond, it can be right on the left side or it can be on the right side. So all of this data is an outlier, right? So I will use this concept and this and I will implement exactly in the same way, right? So to implement this on a Python, I am going to the Google Colab, and you can search it on Google, and I click on the new notebook. So basically this is the Google Colab here, and I have to just import some sort of libraries first. Import NumPy as NP. This is the important Python library. Import matplotlib.pyplot as plt, right? So these are the two important libraries from the Python. You can import it from here. And the first thing I wanted to discuss is I'm just defining the data set, right? So I'm defining the data set, and like here, data set, and I'm just randomly generating the data set. Let's say 925. So I have to apply in this data set, I have to apply a z-score method. I have to identify those outliers, and then I have to remove those outliers. So what I will gonna do here is that at the z-score method, I told you before in my previous session, we were doing z is equals to xi minus mu divided by standard deviation. This is basically your mean, and this is basically your standard deviation, right? So this is your standard deviation, this is your mean, and I'll exactly apply this formula in your Python, right? So this is if this is my data set, then I'm defining the z-score. So let's say I'm defining a function here is detect outlier function, which takes data as a parameter. And first of all, what I need to do here is, in order to calculate the z-score, I need two or three things. First, I need this xi, which is the every element that is present in this data set. And then again, I need a mean and also the standard deviation. So for this, I first have to calculate mean. So our mean would be np.mean, and I'll get data, right? So whatever the data set we give here, it will be added here. And again, for the standard deviation, So for the standard deviation, or I can only write here std. Let me write this std np dot std and the data, right? So I calculated mean, I calculated the standard deviation, and the next thing I have to do here is to implement for I in data. So I have to loop across each and every element and try to calculate its z-score, right? So for the z-score formula, if you can watch it here, is z is equals to xi minus u divided by standard deviation. So it would be like z is equals to I minus mean, and if I just take it in a bracket, divided by std, right? Standard deviation. So it will get me a z-score of each value. And one more thing I need to add here is that, yeah, one more thing I need to add here, I guess, is let's say after calculating the z-score, then I need to set a threshold here. I need to set a threshold. Initially, I told you this, that each and every value that is beyond the third standard deviation, I'll consider it as an outlier. So by keeping this assumption here, I am going to set a threshold here. Let's say threshold is 3, right? So threshold is 3, and I have added this thing again. I have to I minus mean divided by standard deviation. After calculating this z, so if np dot absolute z, if this z value is greater than threshold, right? So if this z value is greater than the threshold, right? Why I'm doing this absolute value? Because z-score, if you know about the z-score, if you have watched my videos, then z-score can be either negative and positive. So we are keeping it positive here because we have set the threshold as a positive value. So that's why I'm just taking it as an absolute value here. So np dot absolute z is greater than threshold. Then I have to append all the values to a list. So in order to do that, I have to initialize an empty list, right? So I have initialized the empty list, and if this condition is satisfied, then append those values to the list, right? So sorry, I will not append z, I will append I, because I is the actual values that is present in this data, right? So I will append I into the list, right? So I guess, and in the end, I have to just return the list, right? So I hope you just understand this. So it is working. So let me just call this function, and I'll give this dataset, and it gives me an empty list. Why I am getting the empty list? Because I think in the data that I have defined here, as I've randomly defined this data, it should consider 136, 142, and 139 as an outlier, but it's not detecting the outlier. Maybe I should just slow down the threshold here to 2, maybe, if that works. And yeah, let's see. So it detects these outliers when I lower the threshold, which means that it was a kind of a graph that would be something, I must say, like this. If I say that this is your line here, and your distribution would be like this, right? So your distribution would be like this, and if this is your mean, then maybe it would be containing a second standard deviation till here, right? This would be first and this would be second, and maybe at the third standard deviation it would be lying at this point or at this point. So it won't be able to calculating these things. So if I just appear all of these things that are beyond this and beyond this, so it will just considering those as the outliers. So till here it is not considering the outlier. So I have to lower my threshold so that it can correctly detect the outliers. So it can happen, it depends on the data set that you have, it can happen. So this is the basic implementation of the z-score method. So you have outlier, redirect the outliers. Next, I will talk about the IQR method. For the IQR method, we have some of the steps here. I must say the IQR method. For the IQR method, we have some steps here. The very first step is the arrange the dataset in ascending or descending order, right? Or maybe sort the dataset, right? And the second point we have here is that after arranging the data, the next thing you need to understand is that you need to calculate Q1 and Q3. So calculate Q1 first percentile and the first quartile and the third quartile, and then you can easily calculate the IQR, right? So these are the things that you need to understand here, which is around Q3 minus Q1, and then calculate lower fence, right? And then we have to calculate upper fence, right? So these are the steps of the IQR. Now we have to arrange the dataset first in the order. So we have to just arrange the dataset here. So dataset is equals to np dot, maybe there is a sort, yes, sort dataset, right? So it will sort your dataset, and let me just see my dataset here. Yes, now it is sorted. It is sorted in the ascending order. So this is important while calculating the IQR because it deals with the percentile and it deals with the median also. So the data should be in ordered, either in ascending and descending, but usually when you have the sort, so it will always sort in the ascending order. Then we are completed with the first step. Second step is calculate Q1 and Q3. How you're going to calculate with Q1 and Q3? If you remember about the percentile that I talked about, is that like your Q1 is basically 25% of your total data, total distribution, right? So how you're gonna just calculate this Q1 is the 25 divided by 100, right? And this is multiplied by the total data set plus 1. So this is how you can calculate this Q1. For Q3, you have like 75% of your total data set equals to 75 divided by 100 multiplied by n plus 1, right? So this is how you can calculate this, and in the Python implementation this is really easy. Calculating Q1 and Q3, it is easy. Why? Because let me just consider this Q1. If you wanted to do Q1, then np dot percentile, you can give like dataset, and it is 25%, so you can just make it 25. And for the Q3, what are you going to do? Make it 75, right? So this is how your Q1 and Q3 will be calculated. You can also do this in a single line, which is, if you want to do this in a single line, how you're going to do this: Q1, Q3, and np dot percentile dataset, and you can just pass the list 25 and 75, right? So this is how you can do it in a single line. So it is just an efficient way. Either ways are working fine in a similar way. So you just calculate this, and you can just print like Q1 and Q3. So it would be like 4, and this is the 9.75. Now we are done with our second step. Now moving on to the third step, calculating the IQR. Calculating IQR. So for calculating IQR, I have IQR is equals to Q3 minus Q1. So this so this is how you can calculate IQR. This is 5.75, right? Now we have calculated IQR. Now calculate the lower fence and the upper fence. So what is the formula for the lower fence and the upper fence? So for the lower fence, we have Q1 minus 1.5 and IQR. Similarly, for the upper fence, we have Q3 plus 1.5 IQR, right? So these are the two formulas that we have to implement this. So first of all, I'm just gonna go with lower fence. Lower fence is equals to Q1 minus 1.5 IQR, right? So I just multiply it, maybe I just multiply it and put it in a bracket here. And for the upper fence, I just modify this to plus Q3, and this would be the upper fence, right? So I just calculated this lower fence and the upper fence. You can also just print them, lower fence and the upper fence, right? So all of the values below 4.625 and above 18.375 are the outliers, right? So this is the thing. So yeah, we had like the maximum value that we had in this data set is 12 if according to this IQR method, and minimum was like 1, and all of this value 142, 139 and 136, these three values were the outliers. So these would be like removed from this. So we have this range, and the lower fence we have -4 and the upper fence is 18.375. So this is how IQR method is applied. So it contains these 5 steps, right? And if I wanted to do directly this in my the IQR method in my in a box plot, if I just wanted to do, then import cbond as SNS, and you have to just write SNS dot boxplot and just pass the dataset and just run this. Then you can see here, this is your box plot here. All of the values are lying in here. And these are the 3 values you can see here. This is 139, 136, and 142. So these 3 values are lying at that point, 139, 136, and 142. And all of the rest of the values that are lying in here, right? This is less than 20 because we have the upper fence that is 18.375. So all of the values are lying here. So I in detail I discuss about, I even draw the box plot in one of my videos of the file number summary videos. The easy implementation in Python, but you should know how it is implemented through statistics, right? So I hope you understand this, the Python implementation of the z-score method and IQR method in order to identify these outliers.